2.2, analyze conditional statements. You may want your pen out for this. We're doing a lot of writing today, and you're not going to see very many numbers in this lesson. Lots of vocab to start us out with. Obviously, they're all filled out here for you. I'll go through them. Please stop the video and pause it if you need to copy something down. And remember, you don't have to have everything copied down word for word as long as you understand what it's saying. All right, first one, conditional statements. A logical statement with two parts, a hypothesis and a conclusion, okay? In conditional statement, I just want to kind of point some of these out because we're going to see these words over and over. It is written in an if-then form, which is our next one, a statement that starts out if this, then this. I often use the example, if your room is clean, then you can go to the football game on Friday. So I give a condition. I give you something that you have to work on if your room is clean. And the conclusion is, then this will happen. Okay, so that's an if-then form. The hypothesis is the if part, okay, the if part. If I do this, then this will happen. So that's the deciding factor, the hypothesis. The conclusion is the then part. Then this happens after the first thing does or does not occur, okay? So we have the hypothesis and the conclusion. We have this word negation, okay? And if you think of negate, negative, they all kind of have that same meaning of opposite of the original. So the negation of something. Okay, these next three go back up with the conditional statement, the if-then. I started you out, if you clean your room, then you can go to the football game. These next three take that same statement and just move things around. The converse exchanges the information of the hypothesis and the conclusion. It does not flip the if or the then. But if I started out and said, if you clean your room, then you can go to the football game. The converse flips it around and says, if you go to the football game, then you have to clean your room. Okay? The inverse is the next one on the list, and it says negates the conditional statement. So the conditional is the one we started with, okay? Which said, if you clean your room, then you can go to the game. When I say negate, that means to do the opposite of things. So I say, if you do not clean your room, then you do not go to the game. And the contrapositive comes back to the converse and negates the converse. So that converse was the flip that said, if you go to the game, then you clean your room. Now I'm going to negate that and says, if you do not go to the game, then you do not clean your room. Okay? And we're going to work on a few of these. The more examples you see, the easier it is to understand what these words are doing. Okay, equivalent statements, two statements that are both true or both false. Again, it seems like a silly definition, but as we do some of these, you're going to understand what that means with equivalent statements. Okay, I'm going to tell you right now, this perpendicular lines, this is the most random place they can throw this one, but for some reason, they wanted to use it in the examples in our notes today, so they decided to define perpendicular lines. I'm going to be honest, if you draw two lines and you put a little right angle in those are perpendicular lines, okay? Two lines intersect at a right angle. Just remember that. I'll bring it back up in chapter 3 when we do a whole lot more with perpendicular lines. All right, this last one is another super important one, biconditional statement. It's a statement that contains the if and only if, okay? So again, as we get to those examples, I'll kind of point out where those are going and what we're doing with those biconditional statements. Lots of vocab. I'll walk you through them and hopefully they'll make more sense as we go through the notes. All right, page 2. Okay, writing just the conditional statement or the if-then form, okay? So some ideas that I want you to notice and I want you to be careful on. It is so important that to keep all of us on the same page, we keep the order of what we're trying to do. Okay, let me highlight. I don't know. There we go. Keep the order of the information they give you. That way we all are doing the exact same thing. Okay, and then in the margin, I've also added, you may need to add a category because this will actually help our if-then statements to flow a little better. So we're going to keep the order of what they tell us about, and then if needed, we're going to have a category. So I've given you some examples, shape, animal, person, whatever we are talking about. And I'm going to tell you right now up front too, because it's amazing how many times we use this. Sometimes the word it makes a really good category, okay? So if need be, think about just adding just a little bit of wording so these if-thens flow a little bit. Okay, and here's what we're doing. We're going to start off with this statement. All vertebrates have a backbone. When I say keep the order, that means I want to talk about vertebrates first, backbone second. That's the order we want to keep. So I'm going to turn that into an if. Okay, if something has a vertebrate, then it has a backbone. So I need a little category word. Well, I don't know. You can use something. I'm going to be honest, you can use something. I might say if an animal is a vertebrate, then it has a backbone. Okay, so I kept the order of the information they gave me, and I turned it into an if-then form. Okay, this is my conditional statement, my if-then. Okay, will all of our if-thens look identical? No, but the order of the information should stay identical in everybody's. Okay, so next one on number 1, all triangles have 3 sides. Keep the information in order. So what are triangles? Well, a good category might be a shape. So I might say if a shape is a triangle. So I kept triangles as my first piece of information. If a shape is a triangle, then it has 3 sides. Okay, so I keep the information in the same order. I add that category word just to kind of make my sentence flow. The common mistake, if you say if a triangle, well, now you're talking about triangles as the big category, and then you don't have enough information. So we have to step back and say, wait, I need to make sure they check if they have a triangle. So if a shape is a triangle, then it has 3 sides. All right, second one here, and these algebra ones go a lot faster. When x equals 2, x squared equals 4. So I'm just going to change when to if x equals 2, then x squared equals 4. Okay? So if, then, keep the information in the same order they give it to us in. Okay? So those are conditional statements. Those are the first ones, our if-thens. Okay? Now we're going to work on all of our 4 together. Conditional statements, which is the original if-then. The converse, which is going to switch the if and the then around. The inverse, which is going to put knots on the conditional. And the contrapositive, which is going to put knots on the converse. Okay? Those are coming from our definition on the front page, but I listed them again so that you have these here and they're hopefully easy to use. Okay? And don't worry about the some are true, some are false. We'll do that after we get done. Okay, once again, I'm going to say if you have a pen, you might want to use it because we're doing a lot of writing. I'm going to do my best to keep my writing legible here and hopefully fit them in where we need to. So we're going to start with the if-then. And I do want to stress, when I put these on a quiz or a test, I always keep this order the same. If-then, then the converse, then the inverse, then the contrapositive. So we are going to take this sentence, Olympians are athletes, and we're going to turn them into an if-then. So we need a category. Well, you want to use a person maybe? So we're going to say if a person is an Olympian, then they are an athlete. Okay? So we started off with the Olympian first, athlete second, because that's the order they gave us to us in. If a person is an Olympian, then they are an athlete. Okay? So for the converse, it says switch around. It says if then. I don't mean the if and the then. We're actually going to say, I'm going to keep this category the same to start with. So we start with that, but it's the information behind the if and the then that we're going to switch around. So I'm going to start off, if a person again is an athlete. So I took my information that was in the back before and switched it to the front. If a person is an athlete, then they are an Olympian. Okay. All right, now go into the inverse, okay? And again, if I keep these the same, I just want to stress the inverse goes back to your if-then, okay? So if I think this is my if-then, and it goes back to the inverse, those two both start with an I, okay? Just to kind of remind us there. This inverse goes back to the if-then and puts knots on it, okay? We're going to negate it is what we're saying. So we write, if a person is not an Olympian, then, then they are not an athlete. Okay. And my final one, my contrapositive, which starts with a C, is going to go back to my converse, which starts with a C, and puts knots on my converse. So I'm going up to my converse. I had if a person is an athlete, then they are an Olympian. Now I'm going to put knots on that one. So I get if a person is not an athlete, then they are not an Olympian. Okay? The first one's the hardest to write. You have to find that category. You have to make sure your order's correct. On the converse, sometimes there's a little trouble in the flipping, but remember, if you keep that first little part the same, if you keep the same thing to start every sentence, it keeps your category there. Then we flip the information behind it. The athlete and the Olympian are what we flipped. Those two are the hardest two to write. Then the last two, you simply grab those first two and put knots in them and you're good to go. Okay, you write the opposite of what they are. Now, I wrote at the bottom here, some are true and some are false. So let's go back through our statements and figure out, is this a true statement or a false statement? So the first one, if a person is an Olympian, then they are an athlete. True or false? I would say true. To make the Olympics, you're an athlete, you need to practice hard, you need to train, right? For the converse, if a person is an athlete, then they are an Olympian. True or false? I would say that one has to be false. We have a lot of athletes in our building, but they are not all Olympians. Inverse, if a person is not an Olympian, then they are not an athlete. So if you're not in the Olympics, you can't be an athlete. True or false? I would definitely say false again on that one, okay? And finally, the contrapositive. If a person is not an athlete, then they are not an Olympian. I would say that goes back to true again, because if you're not in athletics at all, you probably aren't going to be competing in the Olympics, okay? So going back to one of our vocab words, they said we have equivalent statements. So two statements that are both true are equivalent. Two statements that are both false, they're equivalent. Doesn't mean they say the exact same thing. It means their truth value of true or false is the same. That's all that means for equivalent statements, okay? Not a huge necessary vocab word for what we need to do here, but I do want to kind of demonstrate what that means. All right, page 3. We start up here with this definition of perpendicular lines. I told you in the definitions, it's kind of random that they put this here in this section, but they have it here. We're going to go with it here, and I'm going to remind you someday in chapter 3 that it's back here in chapter 2. Okay, definition. If two lines intersect to form a right angle, then they are perpendicular lines, okay? Now, this definition can be written using the converse. So if I flip these, if two lines are perpendicular lines, then they intersect to form a right angle. I can flip that either direction, okay? And it still means the same thing. So perpendicular lines, right angle, that's what we're looking for. One thing I do want to tell you is that in the math language, we have a symbol for perpendicular, and that symbol is this upside down T. Okay, that means perpendicular, and you are allowed to use that upside down T as the word perpendicular anywhere in your writing. So if you're writing a sentence in geometry and you want to say perpendicular, you can use that symbol. If you are just writing an answer to something and something's perpendicular, you can use that. You'll notice that we use it between lines or segments and such as that symbol to tell you things are perpendicular. So that symbol is universal in math. You can use it at any time for perpendicular. All right, so let's look at example 3 here. It says, decide whether each statement about the diagram is true. Explain your answer using the definitions you have learned, okay? So it's asking you first, is line AC, that's this one right here, is it perpendicular to BD? True or false? Well, they give me that right angle, so I can definitely say true. I'll tell you what, if that right angle was not there, you cannot assume that. So this one is true. The lines intersect to form a right angle, and you can say the lines are perpendicular, okay? The second one here, looking at the same picture, it says, is the statement AED, let me find a color here, AED, so AED is this angle right here, and BEC, that's this angle over here, are they a linear pair? Remember, a linear pair draws a straight line and two angles side by side. Are those two side by side? No. So this statement is false because those angles are not adjacent angles is kind of what they're looking for. They need to be side by side, that word adjacent. And so these are not a linear pair. Okay? And you're going to have some in your homework where you're going through and you're saying, does this picture or does how things are marked, do they fit that definition? And basically step back and say, what was the definition? You might need to flip back in your notes to check one and say, does this picture match that definition? Okay, at the bottom of this page, we're going to do our first example and really work on these biconditional statements. So I have a note for you here that I do definitely want you to copy because this is so important. You can only write a biconditional if the conditional and the converse are true. So when you're doing those lists of if-then, converse, inverse, and contrapositive, you want your if-then and your converse to both be true. If you can't say they're both true, you cannot write a biconditional. And I can't stress this enough. This is going to be a question on a test or quiz somewhere along the way. So keep that in mind. I need a true on both the first and the second statement, both the if, then, and the converse. Then I can write a biconditional. Otherwise, I just say no biconditional can be written. Okay. In the margin, I have some steps to write a biconditional statement. We're going to write the converse. We're going to turn the converse into the if and only if. And I'm going to add one, and I should type it up someday, but I don't have it. And the way we're going to do that, we're going to take away the if and replace the then. Okay, so my then part, that's what we're going to replace with if and only if. So we're taking away the if, and we're going to replace the then with if and only if. Okay, so let's practice this and try this with this statement. So we get the first statement. If two lines lie in the same plane and do not intersect, then they are parallel. So let's see what they're telling us. So here's my plane. Two lines lie in the same plane and they never touch. Are they parallel? I would definitely say that's a true statement. Okay, let's write the flip, the converse, okay? And remember, this is kind of my category here, right? If two lines. So we're going to say if two lines. The converse flips our information around. So if two lines are parallel, then they lie in the same plane. And do not intersect. All right, so there's my converse. So I check my first one, it was true. Now I check what I just wrote for the converse. If two lines are parallel, will they lie in the same plane and not intersect? And that's a true, okay? That's also a true. So definitely both of those are true. Because they're both true, I can now write my converse, okay? So writing my, I'm sorry, not my converse, my biconditional. So writing my biconditional, I'm going to take away the if from the converse, and I'm going to replace the then with if and only if. And other than that, I don't do anything else. I just take the words I have. So I write two lines are parallel if and only if they lie in the same plane and do not intersect. Okay, so take away the if and replace the then with if and only if, okay? You don't have to think of new wording, you just pull from that other converse sentence and you go from there, okay? All right, fourth page, fourth and final for today, right? Okay, write the if-then form, the converse, the inverse, and the contrapositive of the conditional statement, squares or rectangles, and then decide whether each statement is true or false. Okay, so we need a category. Squares, what are squares? We can go with a shape, that'll work. Okay, so let's start with my conditional. Okay, also known as my if-then, okay? Okay, so we are writing squares or rectangles in an if-then. So we're going to say if a shape, there's my category, is a square, then it is a rectangle. Okay. Moving to the next one in line is always the converse. Again, the more we keep these in order, the easier it will be for our brain to process how we have to make the change. I'm going to keep my category, if a shape, but now I'm going to flip my information. If a shape is a rectangle, then it is a square. All right, next one in line is my inverse. Remember, that's going to go back and put knots on my if then. So if a shape is not a square, then it is not a rectangle. And our final one is the contrapositive. And the contrapositive goes back to the converse and just puts knots there. If a shape is not a rectangle, then it is not a square. All right, I think we have them all. Now the question is, are these statements true or false? So we'll start with the first one. If a shape is a square, is it a rectangle? And we're a little bit ahead of ourselves here. In chapter 8, we'll actually give a lot of details. But a rectangle basically just says, I need to have 4 right angles. So does a square have 4 right angles? Sure. That one's going to be a true. Okay, converse. If a shape is a rectangle, will it always be a square? Not always, so we have to give a false on that one. If a shape is not a square, does it mean that it's also not a rectangle? That's also going to be a false for us. If a shape is not a rectangle, does that mean it's not a square? And that has to be true. If you can't say it's a rectangle, you can't say it's a square. Okay? All right, moving on here. Decide whether each statement about your diagram is true and explain your answer using definitions we've learned. Okay, first one here is angle GLK. GLK is this angle down here, and angle JKL. JLK, I said that wrong, JLK. Are they supplementary? And I would say true, right? They equal 180 degrees together. A line always does. Okay, second one says, look at that picture, is JG, yeah, let me erase so we can see it since I scribbled all over it, is GJ and HK, are they perpendicular? And we're going to have to say false, not because we're not sure if it is, but it's not marked. If you can't guarantee it, do not say it's perpendicular. So we'll just put not marked, okay? All right. Write this statement below as biconditional. Because they have said write it as there, we're going to assume the conditional and the converse are both true, okay? In fact, I would say the conditional here is the one on top. This is my if then, okay? That says if a student is a boy, he will be in group A. And then, don't ask me if I can spell because I can't. No, that might be right, conditional, okay. Then your converse is down here. If a student is in group A, the student must be a boy. So they've already done our flip for us, okay? Because they tell me biconditional, we are just going to assume true on both, even though, to be honest, we don't know, right? But they tell us we can write a biconditional. So writing the biconditional, you're going to take your converse, right? You're going to take that second one. We're going to get rid of the if, and the then would be right there, okay? And that's where we're going to put our if and only if. So we're going to put a student is in group A if and only if the student, we're going to change our wording slightly, the student is a boy, okay? Because they didn't write the then there, they did the must, but we can kind of change that. So a student is in group A if and only if the student is a boy. The important thing for the biconditional is we see this if and only if in the middle. Okay, page 82 to 84. I have written down here 3 through 6 all, 8 through 28 even. And for some reason, let me double check that that's what I wanted to keep you on. I do. That's what I want you to do. So 3 through 6 all, 8 through 28 even. You're in your book, and I will tell you, number 8 and number 10 have 4 parts to them. Make sure you include those 4 parts if you want all your credit on that homework. If you have questions, let me know.